In this lesson, we are going to be talking about solving equations, but some special cases. The first type of equations we're going to be looking at are equations that have no solution and equations that have an infinite number of solutions, which means every single number is a possible solution. Let's take a look at our no solution option. When solving these equations, we still follow our multi-step with variables on both sides steps. So looking at the left side of our table, we're going to start by distributing -4 to everything inside the parentheses, which would result in -8x minus 4 equals -8x minus 2. Our next step is to combine like terms. Taking a look at our left and right side, we do not have any like terms to combine. Next, we need to bring our variable term from the right over to the left. So we are going to add 8x to both sides. -8x plus 8x cancels out, so we are left with -4 on the left, equals -8x plus 8x cancels out again, and we are left with -2. So you can see how this is a special case. -4 equals -2 is not a true statement. If we get an answer like this, then we know there is no solution. The way we denote no solution is a 0 with a line through it. This means that there is no possible number that we could substitute in for x that would make this equation true. Let's take a look at what an infinite number of solution might look like. Still, we want to follow our steps of solving multi-step equations with variables on both sides, so we're going to start by distributing our 3 to everything inside the parentheses, which would result in -5 minus 9x equals 3 minus 9x minus 8. Taking a look at the left side, we do not have any like terms, so we'll go ahead and bring down -5 minus 9x equals. On the right side, we can combine 3 and -8. I'm going to go ahead and bring down my -9x, and 3 minus 8 is -5. Next, we want to bring our variable term over to the left side, so we are going to add 9x to both sides. This would result in -5 equals -5. So again, you can see why this would be a special case. I'm no longer left with a variable, but I am left with a true statement. -5 does in fact equal -5. When we get an answer like this, we have an infinite number of solutions. And the way we denote this is with the infinity sign. This means every single number that you can think of, if we substitute it in for x, it would result in a true equation. Let's take a look at a few examples. Number 1. We are going to start by distributing 3, which would result in 6x plus 6 minus 3x equals 6 plus 3x. Next, we want to combine like terms, so I can combine 6x minus 3x on the left. This would result in 3x plus 6 equals 6 plus 3x. Next, we want to move our variable term from the right to the left by subtracting 3x from both sides. 3x minus 3x cancels out, so I am left with 6 equals 6. Again, 3x minus 3x cancels out. So I'm left with a solution of 6 equals 6. This is a true statement, so I know I have an infinite number of solutions. Number 2, we have parentheses, so we're going to apply the distributive property, and in this problem we need to apply that property twice. 6 times 2 is 12x. 6 times negative 6 is negative 36, equals negative 7 times negative 2 is a positive 14x. Negative 7 times positive 4 is a negative 28. I do not have any like terms on the left or the right, so I can move to moving my variable term from the right to the left side of my equation. I'm going to do that by subtracting 14x from both sides. This will result in negative 2x minus 36 equals negative 28. I'm going to add 36 to both sides. Negative 2x equals negative 28 plus 36 equals 8. Then I'm going to divide both sides by negative 2 with a final answer of x equals negative 4. This is an equation that has one solution as its answer. X equals negative 4. So we can have no solution, an infinite number of solutions, or one solution. So far, we have looked at equations mainly with one solution, like x equals negative 4. But you can get solutions like number 1, an infinite number, or no solution. These are all three possibilities. Let's take a look at number 3. On number 3, we want to distribute the 8 to everything inside the parentheses and the 6 to everything inside the parentheses. This will result in 40x minus 24 equals negative 18x minus 24. We do not have any terms to combine, so we are going to next move our variable term from the right to the left by doing the opposite, adding 18x to both sides. 40x plus 18x is 58x minus 24 equals negative 24. We are going to add 24 to both sides to get 58x equals 0. So you might be tempted here when you have negative 24 plus 24 to mark those out, because that's what we did on the left side. But remember, with an equation, you have to have something almost like a placeholder on both sides of the equation. You can't leave one side blank. So we must put a 0 on the right side. Next, I'm going to divide both sides by 58, which will result in x equals 0. 0 divided by 58 is 0. This equation has one solution. X equals 0. Let's take a look at one more. On this last problem, we want to distribute twice. We're going to distribute our 7 to x and 7 to 2, as well as distributing negative 4 to x and negative 4 to negative 7. On the left side, we're going to go ahead and bring down our 3x minus 13 equals 7 times x is 7x, and 7 times 2 is a positive 14. When I distribute the second time, negative 4 times x is negative 4x, and negative 4 times negative 7 is a positive 28. Next, I need to check to see if I have any like terms. I do not have any like terms on the left side, so I'm going to go ahead and bring down that side of my equation. I do have like terms on the right side. I can combine 7x and negative 4x. When I combine these two, I get 3x. I can also combine 14 plus 28. 14 plus 28 results in a positive 42. Now that I've combined my like terms, I can move my variable term from the right to the left by doing the opposite operation. so I'm going to subtract 3x from both sides. When I subtract 3x from both sides, this results in negative 13 equals 42, which is not a true statement. Since this is not a true statement, I have no solution. Remember to denote no solution with a 0 with a line through it. Next, we are going to look at solving literal equations. First, we need to know what a literal equation is. A literal equation is an equation with multiple variables. And literal equations are mainly used a lot of times in science and in real-world problems. We've also seen real-world equations in math. Anytime you're using a formula, this is a literal equation. So before we start looking at solving these literal equations, let's review quickly how we solve two-step equations. So the two-step equation we have on the left is a fairly simple equation. Remember, the purpose of solving an equation is to isolate the variable. By isolating the variable, we are eliminating or getting rid of the other numbers that are on that same side of the equal sign as my variable. So for the problem on the left, we need to get rid of the 2 and we need to get rid of the minus 5. And we do this by doing the opposite. So instead of subtracting 5, we are going to add 5 to both sides, which results in 2x equals 18. And then instead of multiplying by 2, we divide by 2, which then results in x equals 9. Well, we can apply the same principle to the problem on the right. If you notice, the problem on the right is very similar to the problem on the left, with some minor differences, and we'll talk about that in just a minute. To solve the problem on the right, we want to add b to both sides. When I add b to both sides, this does not change the ax. However, negative b plus b cancels each other out. Equals, I cannot technically add c plus b because they are not like terms. So I have to write that out, c plus b. Next, we're still solving for x, so our goal is to isolate the x. I still need to get rid of the a. To get rid of that a, I'm going to do the opposite, and instead of multiplying by a, we're going to divide by a, which would result in x equals, since I don't know the values of a, b, and c, I can't technically solve them or evaluate them, so I have to leave my equation as c plus b divided by a. Now the purpose was to solve for x, and when we solve for x, we know we're done when our x variable is isolated or by itself. And at this point it is, so I know I am done. So what I want you to do is pause the video and compare these two problems on the right and on the left, and just make a few notes in the space about what you noticed that was similar and about what you noticed was different. Go ahead and pause the video and write your thoughts down. So what you may have noticed is that both use the opposite operation. So when I went to solve them, instead of subtracting 5 or subtracting b, I did the opposite and added. As well as instead of multiplying by 2 or multiplying by a, I did the opposite and divided. Something else you may have noticed is that the literal equation doesn't simplify nicely, and that's because there's multiple variables. So you may have noticed that the literal equation has a messy answer. But all we're doing when we are solving literal equations is moving our variables around. And we do this so that when we apply this equation, it's a lot easier to work with later on. Let's look at several literal equations and how we would solve them. Number 1, it's very important when solving literal equations that you read which variable you're solving for. And for these basic skill problems, they will tell us specifically, solve for W or solve for H. So it's going to specifically tell you which variable to solve for. Number 1, A equals L times W. Area equals length times width. Wants me to solve for W. So that means I need to get rid of L. L and W are put together with multiplication. So what is going to separate these two is division. So instead of multiplying by L, we're going to divide by L. A divided by L, I can't technically do this, so it stays A divided by L. Equals L divided by L equals 1, so I just have 1W. And as we know, we don't have to put the 1 in front of the W, it's understood to be there. And then lastly, I'm going to flip my equation around so it reads W equals A divided by L. So that the variable I'm solving for is on the left and the rest of my equation is on the right. So when solving these literal equations, you should end with the same variables and the same number of variables that you began with. We're simply moving them around. Number 2 wants us to solve for H. H and B are held together with multiplication. So to isolate H, I must get rid of B by doing the opposite. The opposite of multiplying by B would be to divide by B. And we're going to do this to both sides. Well, technically, I can't divide A divided by B, so it simply stays A divided by B. Equals B divided by B is 1, so I simply have 1H, or H. And then again, we want to flip it around so the variable we're solving for, H, is on the left. H equals A divided by B. Make sure if the letters are uppercase that they remain uppercase throughout the whole problem into your answer. And if they are lowercase, that you do the same. Let's take a look at number 3. Number 3 wants us to solve for T. T and R are held together with multiplication. So in order to get rid of R, we need to divide by R. D divided by R is D divided by R. Equals R divided by R is 1T. Again, we have 1 as an imaginary number, so we don't need to write it in front of the T. And we want the variable we're solving for on the left, so we want to flip our final answer around so that it is T equals D divided by R. Number 4. Number 4 wants us to solve for T. Well, if you notice on number 4, we have 4 variables. I equals PRT. The PRT are all put together with multiplication. So to isolate T, we must get rid of P and R. And since they're both put together with multiplication, I can get rid of them both in the same step. So instead of multiplying times PR, I'm going to divide by PR. I divided by PR is simply I divided by PR. equals P divided by P is 1, R divided by R is 1, so I just have T. Remember, we do not have to put the 1 in front of the T. And we want our variable we're solving for on the left, so T equals I divided by PR. Let's skip down to number 6. Go ahead and highlight number 5. Number 6 wants us to solve for R. The other variables we have with R is the pi symbol, which we can treat like a variable even though we know it represents a number, and the squared symbol. So the first thing we want to do is get rid of that pi symbol. Instead of multiplying by pi, we're going to divide by pi. Because remember, when pi and R are side by side, that means to multiply. This results in A divided by pi equals R squared, because pi divided by pi is 1. We're solving for R, and R is not quite by itself. We still have to get rid of the squared. Well, that might bring you to the question, what is the opposite of squaring something? The opposite of squaring something is to find the square root. So in order to get rid of the squared, we must find the square root of both sides. So what this does on the left side is just the square root of A over pi. Since we don't actually know those values, we can't actually find the square root of them. Equals, on the right side, the square root symbol and the squared symbol cancel each other out. So all you have left is R. But then again, remember, you want the variable you're solving for to be on the right. So your final answer would be R equals the square root of A divided by pi. Number 7 wants us to solve for C. In order to solve for C, we must get rid of minus S. To get rid of minus S, we must add S. We can't technically add M and S together, so we must write it M plus S equals C. Negative S plus S cancels out. And then again, flipping it so that it reads C equals M plus S. Number 8 wants us to solve for M. So that means we need to get rid of divided by V. The opposite of dividing by V is to multiply both sides by V. D times V is represented by D times V. Just writing those variables side by side because we can't actually multiply them. But writing two variables side by side shows the multiplication. Equals, divide by V and times V cancel each other out, so all you have left is M. M equals D times V. Let's look at some more challenging problems that require multiple steps. So when you're doing these problems that require multiple steps, if you haven't noticed, when solving equations, we're basically doing PEMDAS backwards. So this might be helpful to write your PEMDAS acronym and work backwards as you're doing these multi-step ones. So let's look at number 9. Number 9 wants us to solve for H. Well, in order to solve for H, we're going to start by getting rid of the B. 1/2 B and H are all multiplied together. So to undo those or to get rid of the B, we have to start by dividing by B, which would result in A divided by B equals 1/2 H, because B divided by B is just 1. Well, then I have to get rid of the 1/2. In order to get rid of 1/2, remember, 1/2 times H, so the opposite of multiplying by a half is to divide by a half. and that gets super messy. But dividing by a half simply means multiplying by 2. So we would write that as 2a divided by b equals h. Because remember, 1/2 divided by 1/2 is just 1. So we only have h on that side. And over here on the left side, dividing by a half meant to multiply this side by 2. That is how we got the 2a divided by b. Let's take a look at number 10. Number 10 wants us to solve for b. So we want to do the same thing. We're going to start by getting rid of the h. So instead of multiplying by h, we divide by h, which results in v divided by h equals 1/3 b. Then, to get rid of the 1/3, instead of multiplying by 1/3, we divide by 1/3. Dividing by 1/3 is like multiplying by 3. So basically we're multiplying the left side times 3, which is 3v divided by h equals, on the right side, 1/3 divided by 1/3 is 1, so all we have on the right is b. And then I think I forgot on the last problem, but make sure you flip it. So it would be b equals 3v over h. Let's look at a few more because these can get pretty complicated. On number 11, we want to solve for m. That means we have to get rid of v, we have to get rid of the squared, and we have to get rid of the divide by 2. I'm going to go ahead and start by getting rid of the divide by 2. The opposite of dividing by 2 is to multiply by 2. 2 times k is 2k equals, dividing by k and multiplying by k cancel out, so you're just left with mv squared. And remember, we're trying to isolate the m. Next, I'm going to go ahead and get rid of the v squared all in one step. And I can do this because both the v and the squared need to be moved to the other side. In the previous problem that we had a squared, I had to separate that variable and squared. But in this example, those don't have to be separated because they're both moving to the other side. So instead of multiplying m times v squared, the opposite would be to divide by v squared, which results in 2k divided by v squared equals m. And we're going to flip that around. M equals 2k divided by v squared. Go ahead and highlight number 12 and 13. And let's take a look at number 14. Number 14 wants us to solve for y. In order to solve for y, I'm going to start by getting rid of the ax, similar to how we do other equations that have constants and coefficients. To get rid of the ax, I'm going to do the opposite. Instead of a positive ax, we subtract ax from both sides. Well, on the left side, that cancels out, so I'm just left with by. But on the right side, I can't technically subtract that, so we just write it out, c minus ax. I still need to get rid of my b, so instead of times b, we divide by b, which results in y equals c minus ax divided by b. Remember, when you're solving these, we're basically moving our variables around. So whatever variables you began with, you should have those same variables in your final answer, just moved around in a different order. Go ahead and highlight number 15 and 16. And then we're going to mark out 17 and 18.